opportunity to enjoy advanced physics. How are you, everybody who is watching this program? I'm very happy to have you. I will take this opportunity to welcome you into this fantastic program of learning the beauty of advanced physics, advanced chemistry, advanced mathematics, and basic applied mathematics for advanced students or for advanced education. Firstly, I would like to welcome you into one of our online schools that's called the Tanzania Online&Neki Secondary School in square bracket Olenjolai&Neki. Secondly, because I'm teaching you advanced mathematics and basic applied mathematics from 5 and Form 3, from 5 and Form 6, I'd like to welcome you into one of our official YouTube channel that's called Tanzania Online A-Level Secondary School in square bracket Olenjolai&Neki. That is our YouTube official channel, and the address is this one, Tanzania Online A-Level Secondary School in square bracket Olenjolai&Neki. So I thank you for being welcomed, because I know that you are inside right now. And then the next, you have many questions that you are asking yourself concerning about this program. If it's your first time, well, it's good actually to ask yourself so many questions and find something which is meaningful in your life. We honor all our students, all our advanced secondary education students in Tanzania who are school candidates, whether private or who are studying private or government schools. We honor even the receipters, the advanced certificate secondary education examination receipters who are receiving the Form 6 exam. We really welcome you, and we'd like to welcome you another group of honorary diploma who are applying physics in different aspects of life, and even if they have course or modules in order for them to cover some topics of auto physics. And those topics that is the one that we are going to teach you. However, at an advanced level, we have to go further, or we have to teach you in depth. We have to teach you all of those topics in depth. But for the diploma, it's just to get the concepts and how we can apply in different aspects of engineering or science. So one of the questions that you have in your mind, what divisions of Tanzania Online Advanced Secondary School, square bracket Olenjolai&Neki? That's a very good question, and actually really appreciate that question. So the vision we have, the picture which has been written in my mind, the vision we have is actually we have a responsibility to teach and train advanced secondary students about how they can extract knowledge, understanding, and wisdom from the classroom instructions in advanced science and advanced mathematics, and combine it with the knowledge, understanding, and wisdom that we are going to teach them to extract from the Word of God, written in the Holy Bible, in order to solve real-life problems. You are an advanced secondary student, you have to think that, and you have always to remember there is a particular problem that waits your solution. So you should not wait, should not procrastinate, should not postpone, but you have to make sure that it's a time right now. I have to think, how can I solve that particular problems according to your gift, right? So that is what you're going to. So the main objective of TOASO, which is Tanzania Online Advanced Secondary School in square bracket Olenjolai, is to teach advanced secondary students on how they can understand the information that they are supposed to have, and how and where they can apply. So we are teaching you the theoretical concepts of the idea, but you have a responsibility also to convey the message in real life problems, right? That's very important. Again, whenever you go into any physical advanced secondary students, the first thing that you have to do is registration. So even myself, when I was planning, or I was drafting this session, then I said, okay, I would like to share with my student some steps that can help him or her to be registered permanently. The good thing that in this, if you register yourself in Tanzania Online A-Level Secondary School in square bracket Olenjolai&Neki, is actually find that yes, registrations, okay, registration. So actually find that you just do one registration for one lifetime's registration. It's not like the normal physical schools where you do registrations every term, right? If you do one registration here, it's lifetime. Even if after 10 years, if you come back, you'll find you are still registered. Okay? So the first step on registrations, you have to create or open a new email. Example, so this is the example Yahoo or Gmail. In case you don't have an email. If you have an email, you just skip the first step. You go to the second step. Sign in YouTube by using the email you have created. The aim for you to create an email is in order to be able to sign in YouTube. How can you create an email? Simple. When you are online, just go to Firefox or go to Google search engine and then search how can I create a new email. Just write a question like that. How can I create a new email? Then you'll be given several ways of how you can achieve it. So after you create your email, what we need for you to sign in, we need your username and your password. Wonderful. And that email you'll be using when you'll be joining to your graduate studies. When you'll be applying for the HESLIPs, applying loans from HESLIPs, maybe applying at particular institutions at NECTA or at TCU. So you need the email. Even myself, my first email, I created it when I was joining or when I was applying for higher education level or for undergraduate level. The third step, now you're already in YouTube, then search to ASO. Don't write the word else. To ASO, it's the abbreviations of Tanzania Online Advanced Secondary School in square bracket Olenjolai. In terms of the channel, this is the abbreviation of Tanzania Online A-Level Secondary School in square bracket Olenjolai. So this is the abbreviation of this phrase, of this name. And that's the abbreviations of this YouTube channel now, right? So Tanzania Online A-Level Secondary School. So copy this name and the paste. Okay? Afterwards, once you click there, you see the icons. You see the channel, which has an icon like this. And here there's the national flag of Tanzania. So I'm a Tanzanian, so I'm doing this program dedicated for the Tanzania and also international students. So this is your flag, right? So if that's the case, you say that once you click this, you'll find some more information. You'll find a place which has video. Then you'll find the place, home. Then you have videos, which will display all the videos that you've uploaded. And then you have what? Playlist. Then you have channel. Then you have community. Then you have about. So once you click, you'll see this tablet, this horizontal tablet. So it asks you that at the right hand side, at the bottom of your right hand side, you'll see the word subscribe. So click it, because this is clicker. So once you click it, its text changes from subscribe into subscribing, right? Into subscribe. So then, this is the point. Okay? So this is the point, this is the bell. So you have a bell. So this is the bell. So subscribe me. So click this bell, and then firstly click the buttons of subscribe, and then becoming subscribed, and then click the buttons of 40 of the bell. Then choose the option of 40 of all. So all personalized it and now. So once you choose the options of all, then it's done. So you have already registered it, and that's everything is okay. So click the button again once you're there. Just come into this top horizontal tablets, then click this buttons of playlist, which is called playlist. And then so we've created in every topic or in every chapter, we create a playlist where we collect all the related video from the first video to the last video. So for instance, we have a playlist which is called the current electricity or electric current. Okay? So current electricity or electric current, because here we have to mention the chapter. So it is what this is chapter 2 in sequence of the syllabus. This is chapter 2 and the name is called the current electricity. But let me check. How is it called in the syllabus? Because I have the syllabus here, and even your solution, you have your syllabus book or a copy of it. So is it called the current electricity? Because most names are used interchangeably. Current electricity, yes, current electricity. So this is chapter 2. It's called the current electricity. Current electricity. So you have a playlist of current electricity. So if you visit this playlist of current electricity, you find all the videos. Even if we record maybe 50 videos of current electricity, then you'll find in the collections and have been arranged sequentially. They call them in terms of session. So for example, this is session 3. So you have session 4, session 5, session up to session 20, 21, 22. So that's why we are directing you that you have to make sure that you click this playlist in order to find the particular playlist in a particular topic. So you can find the collections of the videos, because if you'll be just using the uploads, if you go through the videos, through the uploads, then uploads will confuse you, because we are uploading videos for other topics and also for the Form 5 and for the Form 6. So sometimes it's better for you to redeem your time, right? So that's the purpose of you clicking to the playlist. Then number 6, you click like, so you can like these videos. You can share to friends via the Facebook, via WhatsApp, via email, via Twitter, via Telegram, via Instagram, via TikTok. So you can share the link of this video into your friends, because I know you'll be happy once you'll be taking this program. So quick review of session 2. So in session 2, basically what we have taught you, we taught you about the general introductions of electric current, right? So basically, first of all, we define the term electricity. What the meaning of electricity? Then I shared with you about big picture of electricity, where we get the word electricity. And then we shared up to the word current electricity. Then I shared to you about types of electricity. Okay, types of electricity. At the point when we go to it, then we define what the meaning current electricity. What does it mean? Current electricity. Okay, current electricity. Then after define the current electricity, we found SI unity of electric current. SI unit of electric current, the symbol is I, or in some cases this small I, so capital I, or lowercase I. Then we shared to you about the quantity of charge, which is equal to electric current times time, is equal to number of electrons times electronic charge. And then we say that you can divide this by time. So you have electric current is equal to number of electrons per unit time, and hence there's electronic charge of electrons. So here we have current of electron, and this is number of electrons over time. So this is the one of expression. So we have discussed this so many concepts. You can access session 2 or 40 of electric current or current electricity in our YouTube channel. So let us go into today's session. So today we are in the Department of Advanced Physics, and the subject is called Advanced Physics. And this class, this content for the Form 6 or Form 6 students, or class 12, for example, in India, because we are teaching also international students. And this is chapter 2, ladies and gentlemen. It's called the current electricity. And we are in session 3, in which I'm going to teach you about terminology of electric current, but I'm going to teach you a little bit about conductions, okay? Because the subtopic that we are dealing is called the conduction. Okay, conduction. So we'll be dealing about some conductors. So we have an insulator, conductor, and the semiconductor. So we'll be dealing with them. We'll define what are they, what are the examples of these semiconductors. Okay, so that's very interesting, because electric conductions in metals. That's the subtopic then. Electric conduction in metals. So the subtopic is electric conduction in metals. So, ladies and gentlemen, let us begin from one point. We'll give you some other announcement later on. Types of 40. Types of electric. Types of electric conductors. Types of electric conductors. Okay? So I say that in physics, there are three basic types of electric conductors. Three basic types of electric conductors. These are first one is called the conductor or conductors. The second one is called the semiconductor. The third one is called the insulators. Okay? So you have conductors, semiconductors, and what? And insulators. So let me begin with the first type of electric conductor, which is called the conductors. Say conductors. So what are the conductors? Not the question. Okay? What are the conductors? So the fundamental question is what are. So please copy those steps, pause the video and copy those steps for you to register into ASO. What is electrical conductor? The question. So the answer is, we say electrical conductor is a substance. So this is the substance that allows electric current to flow through it by electrons, by either flow or by electrons. So electric conductors is a substance that allow electric current to flow through it by electrons. So this week we define them. Electric conductors are the good conductors of electricity. Okay? So you see, it means that you say that electric conductors, in plural, any electric conductor or all the electric conductors are good conductors of what? Of electricity. So it's an electric conductor is a substance that allows electric current to flow through it by electrons. Next, electric conductors are good conductors of electricity. Electric conductors are good conductors of electricity. Under all electricity, under all conditions, under all conditions of temperature. So I ask you that you can pause the video and then copy those instructions so you can enjoy. Get prepared to enjoy the beauty of advanced physics with Olenjolai. Okay? I'm here to help you, I'm here to encourage you, I'm here to take you from the present state into the next state without any kinds of too much hassle. Okay? So you see that electric conductors are good conductors. So when we ask that mention the good conductors of electricity are conductors. So the good conductors of electricity are conductors, are called conductors. So let me mention some examples. Even yourself can mention. So examples of examples of good conductors or good conductors of electricity is, the first one is iron, which its chemical symbol is Fe. Okay, the second case of iron, then we have what? Again, we say that in pure water. Okay, in pure water. Then again, okay, another good conductor. We have copper. Copper is good conductor. Then we have constantan. Constantan. Okay. So again, you have what? You have silver. Then we have what? Have again aluminium. Aluminium is a good conductor of electricity. Then we have what? Steel. Etc. Okay. Then second type of conductors. It's called the semiconductor. Semiconductors. So we have a question here. What are semiconductors? What are semiconductors? So semiconductors are the materials, are the element of group 4 in the modern periodic table that modern periodic table whose conductivity, modern periodic table whose conductivity So we say semiconductors are the element of group 4 in the modern periodic table whose activity or resistivity lies between conductors and the insulators. Lies between those of insulators and and this one. So remember that another thing that you have to note as excellent physicists mean that only electrons conducts electricity in metals, not in conductors. So the current carrier for conductors is only electrons. So we say that semiconductors are the elements of group 4, plural, as the elements of group 4 in the modern periodic table, whose conductivity or resistivity lies between the conductivity of a conductor and the conductivity of an insulator. What does it mean? So if we arrange these electric materials according to the conductivity, so you'll find that we have, let's say, conductors, and then here we have semiconductors, and here we have insulators. So in terms of conductivity, the conductivity of what of conductor is higher than conductivity of what of semiconductor, and this one also its conductivity is higher than the conductivity of what of insulator. In terms of resistivity is vice versa. Okay, so it means the resistivity or conductivity of semiconductor lies between the conductivity of conductors and the insulators, even in terms of values. Okay, that's the meaning of what of semiconductors. So semiconductors, these are intermediate materials. Okay, so I again say that semiconductors can act as insulators at absolute temperature. Absolute temperature, which are 0 K. I'm not mistaken. Absolute temperature, semiconductors act as insulators, right? Then we say that semiconductors acts as what? As good conductors at room temperature. So you see that's why we call them what? Semiconductors. So the semiconductor, the material, only can act as insulators according to the temperature of the surrounding environments of the semiconductor, and can act as good conductor according to the temperature also. So at absolute temperature, semiconductors act as insulators. At room temperature, semiconductors act as good conductors. So you have to understand. The current carriers in semiconductor. Current carrier in semiconductor are electrons, just like in metals, electrons for in conductors, and the second current carrier call them holes. Holes, because you are going to have p-n junction, you are going to have p-type semiconductor and n-type semiconductor. So the majority carriers in n-type semiconductor are electrons, while minority carriers are what? Are holes. The majority carriers in p semiconductor are holes, while the minority carriers are what? The carriers are electrons. So holes means positive charge. We have the third topic in physics, advanced physics for the Form 16 is called electronics. So we'll be discussing in detail about semiconductors. So example of semiconductors material before we do doping. Examples are silicon, and germanium. These are commonly used in semiconductors. Silicon and germanium. Silicon and germanium. Okay? Those are examples. Then we have the third type of electric conductors. It's called what? Insulator. Ladies and gentlemen, say insulator. It's called the insulator. So ladies and gentlemen, what is the meaning? What is insulator? What is insulator? Right? So insulator we say that the term insulators insulator is a substance which does not allow the flow of electric current at all conditions of temperature. Under all conditions. Under all conditions. Under all conditions of temperature. Under all conditions of temperature. So insulator is a substance which does not allow the flow of electric current under all conditions of temperature. So simply insulators are the bad conductors. These are the bad conductors. The bad conductors of what? Of electricity. What are the examples? You know so many examples because this is not a new term for you. What are the examples of what is of insulator? You can pause the video and mention them. First good example is plastic. Okay? The second good example is nylon. This is organic carbon. And the third example is wood. Wood. Then, first example, because you have PVC, you've got polyvinyl chloride. Okay? So nylon, we have plastic, you have wood. Another example? Does the sand conduct electricity? No. So what again, another example of, and does the skin conduct electricity? No. Or call it skin or leather? Leather. Leather. These are the materials used to make what? To make, for example, shoes or bags, handbags. So, etc., 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 etc. So does the cloth also conduct electricity? No. Okay, so that's all about 3 types of electric conductors. If you have any question, don't hesitate to ask in the comment section. We'll try my level best to help you. Even also some other students, some other teachers around the world will help you. So right now, let us go to some of the terminologies. So terminologies. Of current. Remember that I say the word current, and the word current, electricity, and electric currents are used interchangeably, have the same meaning. The knowledge of current, electricity. The knowledge of current or electricity. Okay? So I say that the first terminology which you have to remind yourself, we taught you during your O-level education about the term, we call it resistance. Say resistance. So let us remind, because we are going to deal with resistance in different aspects of current electricity. So the question is, What is resistance? What is resistance? We have resistor and resistance. You have to understand to make a distinction. This is resistance. Well, we have a resistor. So what is resistance? Okay. So resistance So in physics, resistance is a opposition force It's opposition force against what? Against the flow. So what is resistance? Resistance is opposition. It's opposition force against the flow of electric current. Electric current through the conductor. Through the conductor. Through the conductor. So what is resistance? Resistance is opposition force against the flow of electric current through the conductor. That is one of the definitions. So resistance is the potential difference between 2 points per unit current. Or some of the books define the term resistance. Resistance is the ratio of what? Of potential difference to the electric current. The electric current flowing through the conductor. So resistance is the ratio of potential difference to the electric current flowing through the conductor. So resistance is the ratio of potential difference to the electric current flowing through the conductor. So the symbol of resistance, so in physics, the standard symbol of resistance is R. It's capital R. What is the SI unit of resistance? That's a very simple question. So the SI unit of resistance is ohm. Or this way. So we say that from Ohm's law, which it taught you, we said that potential difference is the proportional to electric current. The potential difference is equal to resistance times current. If you make resistance the subject to divide the current to both sides, then resistance is equal to potential difference of voltage over current. So this is the formula of find resistance. Resistance of the resistor of the conductor. Right? That's the first terminology. The second terminology which we find in common is resistor. Resistor. What's the resistor? What's the resistor? So resistor say that is a electrical substance which possess the flow of electric current through it. Some of the books will define resistance as electronic components. Electronic components. Electronic discrete components. So resistance, electrical, discrete substance. Passive substance. So resistor is a passive. It is passive component. We have low power resistors, we have high power resistors. So we have to know that resistance is a property. Why resistors are the components which opposes the flow of electric current. So I want to show you because I'm electronics and telecommunication engineer. By God's grace, that's another 50. So I don't want to teach you only theoretical. So this is the bunch of resistors. So these are the resistors, and then in case you order, this against another bunch of resistors of different values. For example, this one are 510 ohm. Again, we have another bunch of resistors. This is 2.2 kilo ohm. So all of these are resistors. If you look physically, they have the same physical size, but their values of resistance is quite different. So the opposition force of 2.2 kilo ohm is high compared to opposition force of 510 ohm. So these are the resistors, my dear student. I want you to just take advantage because you've been here, you had in different aspects about resistors, and then you thought there's something big. These are quarter power, so it means quarter power resistors. Right? So I believe you've enjoyed it. The good thing that later on, just stay tuned. Later on, the next programs after these programs of science and mathematics will be teaching you the beauty of electronics engineering in solving real-life problems. So you have to stay tuned and be permanent student of the ASO. They will get updates once we develop something new for you. So it's a passive components. Yeah, so you have a low power resistor, we have high power resistors. And resistor, you know, it's a common electronics component of especially like the low power electronics. Then the next terminology this terminology we call the conductance. Conductance. And this the symbol G. So the question is, what is conductance? What is conductance? So simply say that conductance is a reciprocal. Conductance is reciprocal. Conductance is reciprocal form of resistance. Conductance is a reciprocal of resistance. As a unity of conductance of G is what? Ohm or mho. Why? Because remember, conductance we say is the reciprocal of resistance. The center of resistance is ohm. So the center of conductance will be what? Will be per ohm. Number 4. First terminology. Have again the terminology called ohm. Say ohm. So the question is, what is the meaning of ohm? What is the meaning of Ohm? Ohm, say that Ohm is the resistance of a electric conductor is the resistance of electric conductor in which potential difference of 1 volt flow through the conductor between 2 points. Flow through the conductor and cause current of 1 ampere flow. That is. So Ohm is a resistance of electric conductor in which potential difference of 1 volt flow through the conductor and causes current of 1 ampere to flow between the 2 points. Flow between the 2 points. Between 2 points. Now the definitions of Ohm. So Ohm, simply, we need 1 volt of potential difference to flow between 2 points, and that 1 volt will cause the currents of 1 ampere to flow between those 2 points. In case you have any question concerned about this session, don't hesitate to ask me in the comment section on your left hand side, and I'll try my level best to answer your questions. Okay? Then the fifth terminology that we need to understand in current electricity is current density. Ladies and gentlemen, say current density. Very important terminology. Current density. And the symbol is J. Current density. Current density. So we have this question. What is current electricity? What is current density? What is current density? Current density say that is a current. So say what is current density? Current density is a ratio of electric current that flowing through the conductor, through the electric conductor, okay, to the cross-sectional area. So we see that current density is a ratio of electric current that flowing through the electric conductor to the cross-sectional area of the conductor. So it's a ratio of electric current that flowing through the electric conductor to the cross-sectional area of 40 of the conductor. So it's a ratio of electrical current that flowing through the electric conductor to the cross-sectional area of the conductor. So, if that's the case now, we say that that's fine. So it's a current density. Current density, which is, the symbol is J. This is equal, it's a ratio of what? Is the ratio of electric current, the ratio of electric current, which is I, over cross-sectional area, which is A. So simply, current density is equal to electric currents or electric current over cross-sectional area. Then what the essence of electric current? The essence of electric current is ampere. Then the essence of cross-sectional area is meter squared. So simply say again, the SI unit of current density is what? Ampere per meter square. Ampere per meter square. We can keep on relating the equation of current density, because that's why we taught you during our format that physics relates with mathematics. How? In this study, we know that current density is equal to electric current over cross-sectional area. This is question 1. And again, recall what we taught you. Before, previously we taught you that quantity of heat is equal to number of electrons times electronic charge is equal to electric current times time. This is called quantity of charge. Right? So for example, from this equation, NA is equal to I T. So just take this the second equation. Let us make electric current the subject. So divide by time. So you have current times time and divide by time. So time and time cancel. So electric current is equal to number of electrons times electronic charge over time. So simply with this one, we say that electronic charge, number of electrons per unit 30 per unit time. Okay? So it's electric current is equal to number of electrons times electronic charge over time. This will make equation 3. So let us substitute equation 3 into equation 1. So current density, another form of current density, it will be number of electrons times electronic charge over time, and hence times what cross-sectional area. So this is another formula of current density. Welcome, our dear students, into Tanzania Online Advanced Secondary School, and we are enjoying the beauty of advanced physics for the Form 6 students. And this is the second chapter of physics, of advanced physics from 6. Then we have another terminology which will be number 6. The number 6 terminology is called what? Electric mobility. Before electric, let me define drifting velocity first. Drifting velocity. Say with me. Drifting velocity. Huh? So if you hear about drifting velocity, what do you get in your mind? Which kind of this velocity? Drifting velocity. Think again. Drifting velocity. Aha. In order for electric current to be flowing from one point to another point in a conductor, then there should be what? Vibrations or actual movement of of electrons. So that the actual movements of electrons means electrons will possess what? A velocity. And this velocity is what we call in physics drifting velocity. So that's why you have a question: what is drifting velocity? What is drift velocity? That's the question you have. Just put. So drift velocity says that the average velocity of the current carriers in the conductor, or is the distance moved by the charge carriers per unit time taken. So it's the average velocity of the current carriers in the conductor. So drift velocity is not the velocity of one electrons, it's an average. So drift velocity is an average. It's an average. It's an average velocity of current carriers. So this velocity is an average velocity of current carriers. It's average velocity of current carriers in what? In a conductor. In a conductor. So it's an average velocity of the current. So it's an average velocity of what? Of current carriers. Current carriers are the ones which are carrying current in a conductor from one point to another point. So for example, if you have maybe a conductor which is this way, this is point A, point B. So current carriers are the ones, and then I say that the flow of electric current. So I know that current carriers are the ones that are responsible to carry current from point A to point B. And current carriers for the conductors, we say what? Only electrons. Current carriers for the semiconductors are electrons and what? And holes. Current carriers for insulators, there's no any current carriers at all. So in other words, we say that also this drift velocity is the distance moved by the charge carriers per unit time taken. So it's a distance. So simply this is a distance moved by the charge carrier. It's a distance moved by the charge carrier. So it's a distance moved by the charge carriers. Moved by the charge carriers per unit time taken. Per unit time taken. So it's a distance moved by the charge carriers per unit time or unit time taken. So simply say that drift velocity is equal to distance over time taken. So when the conductor, for instance, that you have a conductor which is a hollow conductor like this, and then you find that you have this distance, which is out. So this is point A, this is point B. So that's the kind of the formula. Remember that always, we have discussed with you, that always the flow of electrons is opposite to the flow of electric current. So if the electric current flow from point A to point B, electrons will be moving in the opposite direction. That is by conversion. Okay? So we go for number 7. Electric mobility. Electric mobility. Okay, so the next terminology is called the electric mobility, and its symbol is mu. It's mu. So what is electric mobility? What is electric mobility? So electric mobility, simply say that is a ratio between drift velocity, with the ratio of drift velocity, the ratio of drifting is the ratio of drift velocity to the electric field strength. To the electric field strength. So I say that the electric mobility mu, this is equal to ratio of drift velocity over electric field strength. Electric field strength. So it's a ratio of drift velocity to the electric field strength. So the SI unit now means that we have electric mobility. The SI unit of drift velocity is meter per second, while the SI unit of the field strength is Newton per coulomb. So this one, we find that is meter coulomb, then over Newton seconds. Isn't it? Yeah, so SI unit of what? SI unit of electric mobility is what? Is meter coulomb per Newton second. This is the 67 sorting terminology. The next terminology that we are going to use in this topic, which I will leave it at the homework for you. So number 8, let me remind you about the word called resistivity. Resistivity. Resistivity, what is the symbol of resistivity? Tissue. Resistivity, say resistivity. Okay. What is resistivity in current electricity? What is resistivity? So simply say resistivity is a resistance of a unity length of a conductor of unity cross-sectional area. So resistivity is a resistance of a unity length. The resistance is a resistance of the unity So the resistance of the unity length So is a resistance of the unity length of a conductor of a unity cross-sectional area of the unity length. So is the resistance of what? Of the unity length and the unit cross-sectional area of 40 cross-sectional area of the conductor. So it's the resistance of unit length and unity cross-sectional area. Unity cross-sectional area of a conductor. So it's a resistivity is equal to what? If you remember the formula. It's the resistance times cross-sectional area of a length of the conductor. Okay. So now, I'm about to finish this session, which is session 3, and I invite you into the session 4, when we'll be having revisions of the formula of the current density, or current, which will derive the formula due to the conductions, relate conductions in metals. So we have the homework. This is homework 3. So we have 2 other technology. What is conductivity? What is conductivity in electricity? What does the term conductivity means in electricity? What is conductivity in electricity? The next question, what is electric field strength? All the questions are simple. What is electric field strength? What is electric field strength? What is electric field strength? That's the question that I have. So please make sure that you do that homework and you keep enjoying the beauty of physics the rest of your life. Okay? And I would like to say that this is the end of session 3, which has been titled Terminologies of Electric Current. I thank God who have created me in His own image always, and I thank God who have given a gift of teaching. I thank God who have been with me in the preparations in this moment of teaching. I thank God who have given you a chance to join me. I would like to invite you in the next session, session 4, when we'll be dealing about some other concepts of current in electricity. So I would like again to share with you a few announcements. We have again in Tanzania Online Advanced Secondary Schools in Square Bracket Olenjolai&Neki. We have against our official library, which we call the Tanzania Online Advanced Library. So in this library, you can access some of the materials. For example, you can access physics syllabus for advanced secondary education from 5 to from 6. It's cheap, actually, compared to the price of the local shop. So you can order this book and then we can ship it to you. Again, if that's enough, we have also a reference book, which is called Eastern Principles of Photophysics. So this is the reference book. It's a sample of the reference book. We have so many. We have the Principles of Physics by Roger Lancaster. We have again Understanding. We have again another book, Principles of Physics by Nyakon and Parker. So you have so many. So you have again Tom Duncan. That's what we call it, Tom Duncan. So you have a decisions to decide yourself where are you heading to, right? Then we have a question and answer book. This is the Advanced Physics 1 review. So it's Advanced Physics 1 review. What does it mean? You have done with this. Okay? So it means that these are comprises certificate secondary education examination question for the past years. Okay? So it means the students has to go through this stuff as soon as possible. Why? Because you'll find that for you, if you want to be a competent student, you have to do things in advance. You can order also this book. You have again Advanced Physics 2 review, which comprises questions from 2060 to 2020. You can also order this book. It's a NECTA. It comprises NECTA questions. Again, look again about other resources. You can the past papers of test, from midterm testing, of annual, of terminal. So just to keep yourself busy. Okay. So if you order all of this entire package, again, we have scientific calculators for advanced secondary students. So I really insist you that to make sure you order this scientific calculator and use it effectively. Okay? So that's the point that you have. So if you order all of this entire package, there's a great discount that to have is going to give you. Okay? So please also make sure to inform others about this good news for you to have these other materials so you can study further as well as you can. Again, lastly, the last announcement, in case you feel from your heart that you want to offer our Father who is near you a free Thanksgiving for this program, you want to be welcome. This is the telephone number that you can send your Thanksgiving offering any day at any time. But if you hear that voice that you have to do it today, then you can make it even today. Okay? So the registered name is Olenjolai&Neki. I registered the name. In case you want to do the bank transaction, click this button to show more, then see more. Right? So until we meet in the next step. So you are feeling Thanksgiving, but they used it to record other or future or next what. Okay? Just see. Okay, so it means that the main thing, or what will be the function of your feeling Thanksgiving that you offer through to us. The function will be used effectively to pay for the running costing of this program, especially to make everything to be in a high qualified. So may God bless you abundantly. Make sure to do the homework. Let's make sure that you do hard work, and even the next time you have to give me the feedback, whether how far have you gone with this stuff. Okay, so you have to be serious and you have to give us feedback. All right. So may God bless you abundantly once again and protect you until we meet in the next session. So stay enjoying the beauty of advanced physics for the rest of your time life.